So we're on to the last part here. Now, look, to short circuit here, basically you've got an input-output function there. Remember that another name for f of x, by the way, is y. That's going to be really important in a while here. But y is equal to x cubed minus 3x squared minus 9x there. So y, f of x and y are the same fellas. Okay, just all made in Taiwan. So basically you've got an input-output function. So in your calculator, like all I'm doing here is I'm replacing the x, putting in minus 2. My input is minus 2. My output, I'm going to get minus 2. Maybe I'll just show you one of them, just to make sure we get it right. So that's going to be x cubed, so x is minus 2. Then we have minus 3x squared, so x is minus 2 again. My calculator is not great for buttons. And the last one is minus 9. Well, be careful of that. Sure, minus 9 by minus 2. Press equals, and you get minus 2. Input minus 2, output minus 2. Now get your calculator, go back in with your replay buttons. Change that to minus 1, delete 1. Delete 1. And delete 1, giving away marks here with a question like this, and you get 5. Input minus 1, output 5, and I have the rest of the table done here. Put in 0, you get output 0. Put in 1, you get output minus 1. Put in 2, you get minus 22. 3, minus 27, and 4, minus 20. So, remember that they are coordinate pairs, lads. Minus 2, minus 2, minus 1, and 5, 0, and 0, 1, minus 11, 2, minus 22, and 3, minus 27, and then you've got 4, minus 20. So I'm a bit like now your man Gordon, so I'll just finish this off. Minus 2, 5, that's just 5, 0, minus 11, minus 22, minus 27. No harm in showing the examiner how you know how to do one of them in your rough work. No harm there and do that. So here's one. I'm putting it into the oven now, right? Putting it into the oven, and I take it out after about 3 minutes, and this is what I get when I take it out after 3 minutes. Lovely jubbly. So look at, there's all your coordinates. Minus 2, minus 2. Now you need to be pretty accurate here, lads, and always remember this. Look, there's a plus x cubed graph. You were told that there earlier. Plus x cubed, and a plus x cubed, as I always told you in class, a plus x cubed was always the snake, right? Start off positive. If you had a negative x cubed graph, so a plus x cubed graph going up first of all from left to right. If you have a negative x cubed graph, you're going down first from left to right. Okay, so just remember that. Plus x cubed, you're going positive first, negative first there for the negative x cubed. So there's all our points done. You need to be accurate on this. Minus 1, 5, no excuses. 4, minus 20, no excuses. Then things like 1, minus 12, or minus 11, I think, whatever, you end up with that. A smooth curve, lads, not straight lines, as I've seen in exams. Smooth curve. So, next part then is to, taking that now out of the way, so you've got your graph, and you've got here now f of x, so we've got to differentiate x cubed minus 3x squared minus 9x. So we differentiate this, and we get 3x squared minus 6x minus 9. I hope you remember how to do that at this stage. Power by the number in front, 3 by 1 is 3, reduce the power by 1. Power by the number in front, 2 by minus 2 is minus 6, reduce the power by 1, 6x to the power 1. And I told you the trick there was just to drop the x. Obviously I explained why that happens, but this is short circuit time here. So, now what we do is use your derivative. This is the derivative, by the way, but this is obviously your slope function, as I would have told you there. That's your slope function. 3x squared minus 6x minus 9 is your slope function. So obviously there's only two things that can happen here. Put x in, you find out what the slope is, whatever value of x, or put in the slope and find out where that slope is at the value of x that you didn't get out. So and that's what's going to happen here. Use your derivative to find the coordinates of the local max and the local min. So we know at the local max, local min, what do we know about slope? The slope is equal to 0. Right, again, I haven't got time to be going through that. We've done it 1,000 times. So we just let the slope here equal to 0. Here's a slope function. Put in 0 for the slope and find out the values, or the value of x, or values in this case, where that slope is equal to 0. So, you can rewrite it, or you can divide by 3. I'll rewrite it. I'm going to make this a bit easier, which you can do with functions. Divide by 3. It's common to all 2 parts, or all 3 parts I should say. Divide by 3, 1x squared, divide by 3 minus 2, divide by 3 minus 3. Now you've got that, x, the 0, x squared, you're going to factor out to be x, that's a quadratic trinomial. We're solving a quadratic equation here. And we should know that we're going to have some sort of something there. What do we do? Well, we look at the n number, which is 3, get your factor pairs of it, and they must add or subtract to give you the middle number. Well, the only one that's going to happen there is 1 minus 3, and they must multiply. Always do your double check to give you the n number, correctamundo for both of them. So that's going to be end up to be x plus 1, x minus 3, and basically, as I've said a million times, multiply 2 things, you get an answer of 0. One of them must be 0. So, or it could be both of them, but one of them, whatever. So, and you end up getting, take away 1, and you're going to add 3 here and add 3 to the other side. So now, there's your 2 answers for x. We need to find out what y is. And a big common mistake at this stage, hopefully you can see that. Big common mistake at this stage is people sub these back into this fella here, but that's not y. Y, as I said at the start of the question, is this. Y is equal to x cubed minus 3x squared minus 9x. That's what y is. So you've got to come back up here and go y is equal to, I think it was x cubed minus 3x squared minus 9x. Do my t here, as I call it. My t. We're going to sub in x equals minus 1, and we're going to sub in x equals 3. And all along, by the way, I mean, you should have the cop on to be seeing here. Oh, max point is going, or you should be seeing here minus 1 and 3. You know, you can see there where the max and the min points are going to be like. No, you can't. It says use your derivative, so you have to do this. You can't just write down the answers. It says use your derivative. So basically, you swap out the x for whatever you're inputting here. This is just. And oh, by the way, look at it again. They've actually helped you. I forgot about that. They showed you at the start. They showed. Look, lads, at the start. They showed you when you put in minus 1, you got 5, and when you put in 3, you got minus 27. So you've already got it done. You know, when your input is minus 1, your output is 5, and when your input is 3, your output is minus 27. So you could just go straight there, but look at force to habit here, and just in case it ever does come up, I'll do it out the full way. Plug them into your calculator. You'll get an answer of 5. You get an answer of minus 27. So that's now minus 1, 5, and that's now 3 minus 27. So the lucky thing for ye is that on your graph you can clearly see that that's the local max and that that's the local min, isn't it? But if you didn't have a graph, how would you figure it out if you didn't have a graph? You've got the points minus 1, 5, and you've got the points 3 minus 27. How would you figure out which is which if you didn't have that? You'd look at the y part of the coordinate, and hopefully you have the chops to see there that 5 is higher up than minus 27, so the 5 is the local max. I'm just writing this in here just for, I don't know, for the crack. and that one is the local min because it's lower, minus 27, you know. So filling in there, you get minus 1,5 is the local max, and the local min is 3 minus 27. And that is that question done. Oh, right. Sorry, didn't show it to you. Right, sorry if I've missed any parts. That's the end of that.